Gettysburg Seminary presents the Seminary Explorers podcast. Conversations on faith, art, people, politics, theology, life, and more, with voices from around the corner and around the globe.
Welcome. My name is Kristen Largent, and I am the interim dean and professor of systematic theology here at the seminary, and one of the Seminary Explorers podcast hosts. And I'm very delighted to have with us Dr. Sarah Principato, who is in the Department of Environmental Studies down at Gettysburg College. Sarah, welcome.
Thank you. Thank you so much for inviting me.
Yeah, it's great to have you. As we had said in an earlier podcast that I did with Chris Stempfli, this year, Sarah, the seminary was awarded an AAAS grant to talk about science in the seminaries, right? This is not a big part of our curriculum, as you can imagine, but it feels very much to many of us in religion that this is an area that seminarians and the church as a whole really needs exploration, needs more knowledge about, needs a little more conversation with, because again, as you know, there's not only a perception out there that science and religion are really opposed, but there is a lot of hostility, I think, between individuals often. And for me personally, I feel like on the Christian side at least, a lot of that is just some misconceptions and a lot of ignorance, frankly, about science and the scientific disciplines. So I think it's great that you're here, and thought we would just spend some time talking about kind of the work that you do and talking about kind of how that dovetails, how that challenges, I think, in a positive way, an understanding of Scripture and a Christian understanding of God and the world. So, yeah. Well, why don't you start by telling us, you're a geologist. How did you get into geology?
I'm trying to think. I've always been very interested in the outdoors, but also in science and math. And so when I went to college and I took an environmental geology class my first year, I just loved it because we got to study science but be outside, so it was combining two interests very well. And then I just kept on with geology throughout, graduate school and things like that. I don't know how much detail you want about my background, but I went to college at Mount Holyoke College, which was a small college, and then went to University of Wisconsin, where I learned a lot about glaciers and glacial geology.
Yeah.
And I took a field course where we went to Iceland.
Oh, wow.
And
I've heard
got me
Iceland
really
is gorgeous.
hooked. Yeah. So then when I was thinking about doing a PhD, I just knew I wanted to do something with glaciers and ice sheets, and I went to the University of Colorado for my PhD. And I went to Iceland several times, actually, and I continue to do work in Iceland with students at Gettysburg College today.
Well, Sarah, we are not going to bore all of the podcast listeners, but I am from Colorado, and Colorado is like the home of my heart. Yes, Boulder. I lived in Boulder for 2 years, so listeners, you're very grateful that we are just not going to go down the Colorado rabbit hole. But that's right. Oh, that's right. Oh, it's such a great place. Yeah, fabulous. Well, this is sort of a stupid question, but all stupid questions are on the table. What is geology?
So geology is really the study of the earth.
Okay.
And so there are many components of the earth. I teach it with a system approach at Gettysburg, where we look at the different spheres of the earth and then how they're interconnected. So we look not just at the rocks. A lot of people think geology is just rocks.
Right.
But you do have to start with rocks because they leave a long record of history. Rocks and minerals, but it's also looking at the water on the earth, the streams and the oceans and the glaciers, and also the atmosphere is connected to the earth system. Our gaseous envelope around the earth and how that's changing.
Gaseous envelope.
Yeah, and then we have the biosphere component as well, and how, going right down to people and how are we impacted by geologic events. A lot of geologic disasters have a great impact on people.
You talked about the spheres of the earth. What does that mean?
So if you kind of subdivide the earth into different components, you could look just at the geosphere, which is the solid rocks.
Okay.
And, think about things like volcanoes and earthquakes, and that's all part of the geosphere. Or you could look at the hydrosphere, which is just the water.
Oh, okay.
Streams and rivers and oceans and lakes. Or you can look at the atmosphere.
Okay.
Which is most people know what that is.
Yes.
And then, or you can look at the biosphere. And at Gettysburg, we have a lot of students studying ecology, and so they actually have a whole course through our major just on the biosphere. So
okay.
in my particular course, we touch touch on it and how it integrates with the other components, but the students get into more depth in their ecology classes.
So when you apply geology to glaciers, tell me, are you measuring the size of glaciers? Are you looking at the different layers in the glaciers, or what is that? What is that like?
So it depends on what project I'm working on at the time. I'm a glacial geologist, so we use the record that glaciers leave behind to study them and figure out how they varied through time. And one thing we do is try to reconstruct the size of a glacier. How big was it? We look at landforms that the glacier leaves behind that marks out kind of exactly where it was, and you go into the field and you map out places. And trying to think how else I can better explain.
Well, what does it tell you? I mean, what do you learn from this kind of study?
What we're trying to get a sense of how do glaciers and ice sheets change in response to global climate change.
Okay.
And so there's a lot of natural climate variability that we want to understand. And so before you can say what imprint humans have on the climate system, you kind of have to understand how it's naturally varied over geologic time. Okay. So I look also at the ages of landforms and use a variety of dating techniques and things to figure out when the glacier was there. So not just how big was it, but when was it there?
Okay. And all that. What's the neatest thing? What's like one of the neatest things that you've discovered? If a particular glacier in a particular place, what was something that you really thought, this is really cool?
Well, just going to a glacier for the first time. If you've never been to a glacier, I don't know if you have.
I haven't.
So when I take students there, one thing they're very surprised by is that the water melting away from the glacier, that it is so loud.
Really?
It's really loud, and it looks sort of like a river of chocolate milk. It's
all, really? It's dark.
Yeah, it's all silty. There's all clay and silt mixed in from the glacier. Glaciers come down and they carve out the landscape, and they really pick up a lot of rocks and sediment, and then they grind it up and they make what's called glacial flour. And so if you're standing right by a glacial river that's big enough, a big glacier, you can't even hear yourself talk to someone.
Really?
People often go whitewater rafting in Iceland on the glacial meltwater rivers.
Really?
Yeah. And the other thing is that they change in size throughout the day. So I always tell my class this story, how you can go out hiking in the morning and jump across a stream. And then late in the day, you better watch it, because late in the day
you might not be able to get back.
So much you might not be able to get back.
Wow,
so
that's just
really
amazing.
Glacial rivers.
What's the difference between a glacier and an ice sheet?
So an ice sheet is a large glacier, basically.
Okay.
So a glacier can be a variety of sizes, and there's a variety of ways to classify them. The one thing and this is also, I think, really fascinating if you didn't know it before, but glaciers move in the solid state. So the ice crystals are deforming, and they're moving like silly putty. So they're plastically deforming. So to think about a glacier moving, it's not just riding along on a river below.
Okay.
Although meltwater definitely makes it move faster, and they can slide too.
Okay.
So I think that when the students learn that, oh wow, I had a pile of silly putty and now it flowed right down my desk, and they can imagine a glacier
doing the same thing. Oh yeah, that is pretty amazing. Well, again, one of the things, just like at a really basic level, like what I would tell my students, or when I would talk to people in the church of why science is important, is because you can't, as somebody who believes in God, obviously, seeing the wonders of how amazing the world really is, because really most of us, we have such a small little area, and of course there are a million wonders right around us, right? I think you never have to leave Gettysburg to see really amazing things, but I think science expands our vision so much of what's out there, and how things are just so amazing that you just can't, you can't envision unless it's right there before you. And that to me is something that we can't appreciate without scientists and the kind of work that you do. So it's fun to hear that, and kind of imagine your experiences that I haven't had. Well, one of the things, Sarah, that we had said before we started our formal conversation here was that one of the things, of course, about geology for Christians is that it's probably the most, if not one of the most important disciplines in terms of challenging kind of a literalistic understanding of the kind of 24-hour creationist kind of understanding of Scripture. And so I think it's important for us to have a little conversation about that. And so the first thing, again, I think a lot of us are just really ignorant. How exactly does it do that? So, we often hear, well, science says, right, that the kind of a literal interpretation of Scripture is impossible. How does it prove that?
Well, one thing I think that maybe is the hardest to reconcile is the concept of time.
Okay, say more about that.
So I talk about this a lot in my class in the very beginning of the semester. The concept of geologic time, it's very hard to grasp if you haven't ever thought about 4.6 billion years of time, which is the age of the Earth.
And how can you even? Yeah,
it's so long compared to our lifetime. And so what I do in my class is I take them outside on a field, and we have a large, meter tape measure, and we measure out 46 meters, and then I show them kind of major events in geologic time, like when the oceans formed and when the dinosaurs lived, and things people have kind of heard of, and they realize, oh wow, there's no overlap with dinosaurs and people. Oh, okay, my life, and compared to this giant tape measure, is a tiny little slice at the very end. Yeah. And so it probably depends on how you interpret the origin of the Earth and the concept of time that is a little difficult to reconcile.
Yeah. And do geologists, are you also the ones that are dealing with fossils? I mean, isn't the fossil record also part of the issue?
Mm-hmm, there's a really good record of fossils. So before they knew exact ages using a variety of dating techniques, they could just put in relative ages of rocks based on what types of fossils occurred together. And so there will be, a variety of things you could see. You can go just in Gettysburg, you can see dinosaur footprint.
Really?
Yeah.
Where is that?
Oh, maybe a secret.
No.
Not secret. I just took in the battlefield. There's a quarry in York Springs, Pennsylvania.
Oh,
and
okay.
the park used some of the rocks from the quarry to make a bridge on one of the roads near the battlefield. So if you look at the top of the bridge, you can kind of see
dinosaur footprints.
And so
wow.
That's an example of a fossil that we know the environment was very different in Gettysburg, actually, when dinosaurs were living up in York Springs, for example.
How can you tell that from the fossil, Sarah?
Right, so you look at it and you think about the rock that it's in. And so that one in particular is in siltstone. Okay. And so it's and you also see ripple marks and mud cracks, and you get the sense that you're at the edge of a lake. Okay. It's called a rift basin. So Gettysburg is actually a really fascinating place for geology.
Really?
Yeah, because the geology is Mesozoic geology, so we were talking about 200 million years ago. Okay. And people have dated the rocks with a variety of techniques to get their ages. I haven't done that work myself, but it's been published how old they are. Okay. But you can see a place where at Devil's Den, Little Round Top, there's an igneous rock, and that has cut through these sedimentary rocks that are all around the rest of town, which was part of a rift basin, a failed rift basin. And so the geology also influenced the Civil War very significantly, because the igneous rocks that are at Devil's Den and Little Round Top, make the high ground. Devil's Den's lower, but it made them not be able to dig in trenches and things. And then you have the fields where Pickett's Charge that were all, sedimentary rocks that, a recipe for a disaster, right? That flat earth area, and that's all related to the rock that was there and how well it's, what the topography is like. So as a geologist, I look at, the geologic history, but then how does that geology impact people? Yeah. Through a variety of time scales.
You could give, the most interesting battlefield tour. Well, I'd like to go on a battlefield tour with you. I've had enough of hearing about Pickett's Charge. I'd like to hear about the rocks on which Pickett charged.
Well, I am definitely not an expert on Civil War history. history, but I know the basics of the geology. And
that would be...
We're actually, this week, my class is going on around the battlefield.
Oh, how fun. That's so great, yeah.
But then you can also go a little bit further away. I also take my class up to the Shamokin, Centralia area.
I haven't been up there.
And you can find lots of fern fossils from the Pennsylvania time period. So they're much older fossils.
Wow.
So we were talking about fossils to start with, and so you don't have any dinosaurs up there, but you have lots of ferns and tropical trees, and you look at a fossil like that and say, how could you have a tropical tree in Pennsylvania?
Yeah,
it doesn't make any sense. How did this coal bed form here? Coal, forms in a swamp, and we don't have these vast swamps anymore. Yeah. So then you try to think about, well, what would the environment have been like to get this rock to form? And then you realize, Pennsylvania was in a different place. It was 5 degrees south of the equator at this time. And so you kind of link together the fossil record with other things, and the structures, the rocks up there are all folded. And then that area has a big impact on the people because of the coal mining industry.
Sure.
And then the fire at Centralia, the underground coal fire that's burning. So acid mine drainage. And so as Christians, I'm sure, really interested in helping the people deal with a lot of these challenges they face.
Yeah. Well, and of course we'll move to climate change in a minute, because that's such obviously that is something that Christians are very interested in for all kinds of reasons. But I think, again, just hearing you talk about the what do I want to say? The depth, I guess, of the record, right? I mean, the span of time. I think for a lot of Christians, and maybe just kind of people in general, one of the kind of core teachings, right, is this idea that humans are somehow the culmination, right? That all of this. And so, for me, as I hear you talk, I'm just kind of overwhelmed by the amazing, the length that, God has been at work in the world. That's how I would think about that, and all that has come into being and gone out of being. But I think, again, for a lot of people, it feels very threatening then, because right here we are, the tiniest little sliver, right? Yeah. And it's a challenge. But I think knowing more about what science actually teaches about the planet can help us look at, more closely at the scriptural record and think, all right, well, how does this sort of change how we see it? Because again, of course, the Bible's not a science textbook. It was never meant to be that, and so personally, and I know a lot of people Christians who feel this way too, that they really are much more harmonious and actually can really, again, influence each other positively, but we don't always kind of assume that, and you have to sort of get over this idea that it's all about us. It has to be. Well, but before we get to climate change, you had another specialty on your bio, quaternary history.
Okay. The Quaternary period it's back to geologic time.
Oh, it is. Okay.
It's a time period.
Oh, okay. Yeah, when is that time period?
It's a recent time period. It's approximately the last 2 million years through the present.
Oh, I see.
So it's this time period, if you look at the geologic record, which is, as I just said, how old the Earth is, this time period is also just another slice.
Okay.
And it's the time when glaciers and ice sheets expanded and grew and then shrunk and grew and shrunk. A lot of people just know it as the Ice Ages.
Oh, okay. We've seen the movie, the cartoon.
So this time period is what I study. And
and is that typical for people who are interested in glaciers? I mean, this is kind of the formative. Okay.
Yeah, but you can study much older glaciers. Same with the fossil record up in Shamokin, Pennsylvania. You can look at glaciers and places in deposits in Africa that are So I look at the more recent glacial record.
Okay.
And it's also the time period when humans were evolving. And so we have climate and then we have humans and we have a lot going on and we have a pretty good record of it because it's recent.
Okay.
So compared to older rocks that are only preserved in certain places, there's a lot of glacial deposits around the world in a lot of places. So there's more data to look at.
Yeah. Well, all of this leads into, again, I think one of the most important and for me most interesting aspects of your portfolio, and that's the kind of the work that you do with climate change, because again, as you know, this is kind of a flashpoint, not only for Christians, but for a lot of people. And I think, as I was again saying to you, I think some of the resistance to this is not only just because we don't want to have to change our ways, right? Especially in the global north, we're very happy with our big cars and water use and all of that. But I think, personally, and this is just my opinion, so this may actually not be true, but I think there's also something for Christians that the idea that humans can have such a powerfully detrimental, even to the point of disastrous impact on the Earth universe, puts God's sovereignty at risk. And I think for some Christians there's this idea like, oh well, no matter what, God's going to make sure that everything is okay. And to challenge that with this idea that no, actually we could be responsible for the destruction of the planet is threatening that way. So I think it's important for us to talk a little bit about climate change, and again to say, what does that really mean, climate change? I mean, it's a broad term. We throw it around a lot. And what are some of kind of the specific scientific discoveries that are behind that support it?
So climate change encompasses a lot of things, actually. Mm-hmm. You might remember people used to just talk about global warming, focusing just on the global temperatures going up.
Okay.
But climate change refers to more than that. It's including changes in precipitation patterns. Places that, used to have enough precipitation, now they're having longer and longer droughts.
Okay.
And so you have changes in, also sea level is rising in a lot of places around the world. And so you have rising sea level. So it's warming temperature is a piece of climate change, but it's not the whole story. You want to look at whether, not long-term trends over time, what is happening in the Earth. So a lot of these things are related to temperature rising, but in some places climate changes, more storms happening, for example, hurricanes, or there's ocean temperatures rising, ocean acidification. I don't know if you know about that. So the oceans are getting more acidic, and so marine life can't live there as easily as it used to, and that's all related to the amount of carbon dioxide in the atmosphere. So, I could go through a really long, extensive list of some of the components of climate change, but it's really extensive what's included in that.
And just to be clear, I mean, you had mentioned the climate has always been changing, right? I mean, so we have, but what we're talking about here is something different than just kind of natural fluctuations, right?
So it's really important to look at records, which is, I'm not just saying that because I like to look at records. Other people beyond me that study ice cores, so I don't, I read their papers that they publish about ice core data. And the ice core data is the clearest thing, I think. If you're having trouble understanding the impact that humans have on the atmosphere, the ice core record is fantastic.
And tell me what that even means.
So what scientists do is they go to Greenland, Antarctica, a variety of places around the world. Now people can climb up high mountains and core glaciers on mountains too. But the longest records are from Greenland and Antarctica, and the bubbles in the ice record what the atmospheric composition was at the time that layer of snow fell.
Okay, wow,
and then got compacted. So as it turned into ice. So you can figure out the age of the ice, and then by a variety of methods, you can just count layers in some places. You can use dating techniques in others. And then you look at the bubbles, and you can mark how carbon dioxide or methane, greenhouse gases, have changed through time. And over the last 400,000 years, there are a variety of times when it's gone up and down and up and down. Very, natural fluctuation, and it's related to the ice sheets growing and shrinking and growing and shrinking. And then you look at the Industrial Revolution to the present, the very last bit, and the CO2, I'll just use carbon dioxide because I think most people are familiar with it, has skyrocketed above any other time. So the times when the glaciers melt away is called an interglacial time period. And that's when you would expect CO2 to be a little higher naturally.
Why is that? Because there's I'm just gonna. Why is that? Why, when the glacier is receded, would there be more CO2 in there?
Yeah, CO2 and the ice are kind of connected, and there's leads and lags in the record.
Okay.
So generally, the warmer times are when the atmosphere is warmer.
Oh,
sorry, I should have
got it. No,
more.
Listen, I don't know anything, so yeah.
But no, it's a good question. And so then, when you look at the levels of CO2 today, we are well above. This would be something that would be more impressive if I had a graph to draw for you. Kind of hard to explain on a podcast, but just imagine, we've never been above, the natural variability has never been above this certain threshold. And now we are skyrocketing way above it. We're at about 400 parts per million of carbon dioxide. And we've never been that high ever in the natural fluctuations when you would expect it to be high.
Okay.
And so if you look at a graph with the data, and anybody can look at the data, it's free. You can get it on the NASA website.
Okay.
The NOAA website sometimes has records of it too. So it's free data produced by government scientists, measuring what the levels are. For today, they measure it actually out at Hawaii. They have an observatory where they measure CO2 and things. And you compare it with the ice core records through time, and you can clearly see that the levels are so much higher today than in the past. And so to me, there's no way to dispute that. You're looking at what the atmosphere was like. You can't argue with what the atmosphere was like in a bubble. And things like that. And that's relatively, straightforward, I think. There are many other ways to understand that the climate is changing. To map out, rising sea level and all of that, and temperatures in the ocean rising, and there's a lot of other ways to do it as well.
Well, and Sarah, isn't there now somewhere I read, you're going to laugh at the term, but I think this is right, like climate weirding.
Yeah, some people like to use that instead because there's strange things happening.
And I think that's also, it confuses people because, it's not only droughts, but then in other places it can be excessive.
Flooding, you're getting flooding in a place you're not used to getting flooding.
And why might that be the case? I mean, because to me it feels clearer. Okay, so the things that you've talked about, there's more CO2 in the air, that means it's going to be warmer, so that means there's going to be droughts. I can understand the rising sea levels then. But the weird parts, how can you...
Yeah, it's a really good question because everything seems different, then everything seems to be going out of whack. And I think that one of the good analogies by Richard Alley, who's a professor at Penn State, very world-known climate scientist, ice core expert, talks about tipping points. Like you're in a canoe, and when you get CO2, you crank it up just that little bit too much, all of a sudden you reach the tipping point, and just like a canoe would tip over. And so when that happens, everything can go crazy, and we know, there are certain patterns though of things going crazy. Like it's not. So it's very important to monitor what's happening with modern glaciers too, and how they're melting away. Looking at sea ice extent, that's another piece of climate change that has a lot of feedbacks because of the albedo that the sea ice. Do you know what I mean by albedo? No. Should I explain that? So the reflectivity. So when you have an ice sheet, something white. Actually, if you just have something white, it reflects the sun. Keeps things cool. Like on a hot day when you go running, you don't want to wear black. Right?
I know that.
So on a cold day, baby, you don't want to wear black. And it's the same with ice sheets. So if you have sea ice in the Arctic Ocean and a good extent of it, and it's there, it's going to reflect the sun. As it melts away and exposes more of the dark ocean water, it's going to absorb more heat, and then it's going to warm up, and then it'll melt the ice more, and then it'll warm up the ocean, and then it'll melt the ice more. And so it's this loop, this feedback, positive feedback loop, that something that you need to watch.
Oh my gosh.
And it will have an economic importance too. This is kind of an aside, not-expert in this at all, but the shipping routes in the Arctic Ocean may change fairly significantly. So maybe people that are thinking worst case scenario of climate change, maybe they should buy property in Arctic Canada. And right now you wouldn't want to live there, but who knows in 100 years could be.
Well, I think again for Christians, often the place. I mean, it's quite clear, right? God, again, those of us who believe that God created the world and loves it, right, and is still engaged with it, and so I think even though a lot of the science is hard to follow, I think it's important to know and important to understand. But the place that I know the church has often gotten much more actively involved is, like you mentioned, the rising levels of the ocean. Well, some of the islands are disappearing, right? And that's affecting the people who live there. And of course, we all know about the polar bears that are being, so it's hard for me. It's hard for my heart to engage with glaciers. Sorry, but it's much. It's not, but it's much easier for my heart to engage a polar bear, right? I mean, and in terms of trying to understand all of the connections, and I think but often, again, if you don't understand the science, it just feels like, oh well, this is. It's just part of things, and it's but to see, like you were saying, that it's really incontrovertible, that it's at our hand. I mean, that this is happening, and that this is we are creating a situation that's untenable for everything else. Right?
The other thing. Two things I was thinking while you were speaking is that I just want to be clear that scientists are not having a controversy about this. We all are in agreement that the Earth's changing climate.
Okay.
Climate change is real.
Mm-hmm.
There's a very, very extremely small minority of people that might disagree, but I think when you hear the media trying to show something balanced, it's not doing a service to the science, because over 97% of scientists agree that the Earth's climate is changing due to human activity.
Okay,
and so
that's really helpful to hear.
Support for this around the world, and if you go to a different country, they will think you're crazy if you don't believe that the climate is changing, especially in places directly impacted by it. So that's one thing that I get frustrated when people think there's some kind of controversy.
Two sides, right, okay.
And if you look at the funding behind someone's study, that's very important to do, because often people that are trying to find evidence that the climate is not changing are funded by maybe an oil company or an energy company. So you want to look closely at the study and on who's funding it and all of that, and make sure they're actually a person that's trained to study climate change, because some of these studies are published by people that aren't climate experts, and maybe they're a doctor or something, and doctors are excellent at saving lives, but they're not excellent at studying climate change. And so I've seen these kind of papers that get cited by skeptics and it's kind of, or deniers and climate deniers. The other thing I was thinking that maybe, I don't know if in Pennsylvania people can relate to it, but if you're from the Northeast, you could relate to the lobster industry.
Oh, okay.
It was just an article, I'm trying to remember where I read it, about the shift in the lobsters and where they're living now. And people off the coast of Rhode Island, they're having a much harder time catching lobsters. They're all moving further north. And so, these shifts in habitats. You mentioned polar bears.
Sorry. Are you not a polar bear fan?
Definitely afraid of polar bears.
Well, I've never seen a polar bear close up, so I can have this kind of
They eat people.
Yeah, fair enough.
No, but the polar bears will eat more people.
Well, right, that's true.
I have a colleague just at Gettysburg College, Andy Wilson, who studies birds and bird habitats and their migration patterns.
Yeah, of course.
So there's so many organisms you could look at, different species, in addition to people, and not having enough water to drink, or basic things, or their homes getting impacted by hurricanes. They live on certain places in the world.
It does start to feel like there's a level of willful refusal to see what's out there, right? When you talk about all the different ways that you can mark this, and it's interesting. I think, some of us who have a luxury. Okay, my industry isn't fishing. My livelihood isn't based on fishing. I don't live so you can have this luxury of sort of saying, well, it's not affecting me directly at this moment. But again, that's, as the church in particular, Christians in particular. I mean, we're called to care about our neighbor, right? And to be attentive to what's going on in other parts of the world. And so I think for me, this feels like actually, there are actually a lot of theologians who work in this area and work hand in hand with scientists and want to say, this is clearly a problem that demands all of our resources, and everybody kind of needs to get on board. So
I always like to think about the fact that everybody has a right to clean air, breathing clean air, and drinking clean water. I think these things everyone should have an opportunity to have that. And so if we mess with our climate system so much that people don't have that opportunity, then there's definitely something wrong.
No, that's definitely true. Well, Sarah, thank you so much. This has been such an interesting conversation, and I just really appreciate you giving the time, and I think you've given our listeners a lot to think about and hope that we can kind of follow up with, and I'm going to keep you in mind now for this year, and hope to maybe get you up to do something else with us at some point. I think it'd be great. Yeah. So thank you very much.
Thank you.
You have been listening to The Seminary Explores from historic Seminary Ridge in Gettysburg, Pennsylvania, a production of Gettysburg Seminary. We invite you to visit our website at www.ltsg.edu. Opinions expressed on this program are not necessarily those of Gettysburg Seminary or the Evangelical Lutheran Church in America.